Hello and Assalamualaikum. We are from Group 10 and today we are going to present application of Omics data in personalized skincare. This is our group members. For introduction, personalized skincare uses Omics data to tailor treatments based on individual genetics and skin traits. It identifies key biomarkers such as collagen and integrates genetics. This approach addresses unique skin needs for managing pigmentations in darker tones.
Melanogenesis as a protective mechanism against the photo damage. The melanogenesis is a natural process in our body that helps to protect the skin from the photo damage caused by the UV radiation. Some exposure is limit. According to the research, the safe daily exposure to the solar UV radiation is around 2.54 minutes per day. Our skin needs effective melanization, also called the tanning, protect the skin against the UV penetration. The UV radiation has both the benefit and risks. On the positive side, it helps to produce the vitamin D, and the World Health Organization recommend 5 to 15 minutes of sun exposure 2 to 3 times a week. However, too much exposure can cause a photo aging, sunburn, and the skin cancer. This image has shown the example of these harmful effects, such as the wrinkle, skin lesion, and the different type of skin cancer. The first page will divide the skin into 6 types based on how it reacts to the sun exposure. The type 1 burns easily and never tans, while the type 6 never burns and the tans very darkly. Understanding this scale helps us to know how different skin types respond to the UV radiation.
When it comes to skin color, the melanin biosynthesis pathway plays a central role. Melanin is the pigment responsible for the color of our skin, eyes, and hair. There are two main types of melanin, which is eumelanin and pheomelanin. The primary difference between eumelanin and pheomelanin lies in the biochemical pathway that produce them. Eumelanin is produced when the amino acid tyrosine undergoes a series of reactions, while phenylalanine is produced when tyrosine is combined with cysteine. When we expose our skin to sunlight, the skin undergoes a series of adaptive changes to protect itself from the harmful effect of UV radiation. Here's what happens. When we step into the sun, the skin surface, particularly the keratinocytes, absorb the ultraviolet light. UV radiation is a high-energy form of light, and as it penetrates the skin, it can cause direct damage to the DNA within the keratinocytes. This damage may result in mutation that can disrupt normal cell function. However, the skin has a protective mechanism to counteract this. UV light introduces mutation by damaging the DNA, and this triggers the skin cell DNA damage response, which functions as a form of feedback to protect the skin. The DNA damage triggers the activation of a key protein called p53, which is often referred to as the guardian of the genome. P53 acts as a transcription factor, meaning it helps turn on the expression of other genes. One of the proteins activated by p53 is POMC, a precursor protein. POMC is cleaved into smaller fragments, one of which is alpha melanocyte stimulating hormone, which is called it alpha MSH, which play a crucial role in skin pigmentation. Alpha MSH then travel to a specialist cell called melanocytes, which are located in the stratum vessel. Upon reaching the melanocytes, alpha MSH binds to a receptor called MC1R. When alpha MSH binds to the MC1R, it triggers a series of intracellular signaling pathways inside the melanocyte. This signaling cascade results in the upregulation of enzymes and protein necessary to produce melanin, the pigment responsible for skin color.
Genetic polymorphism in constitutive pigmentation across worldwide populations. The human skin pigmentation is determined by the quantity and distribution of melanin, which shows latitude correlated phenotypic variation among populations. Recent studies have found that the single nucleotide polymorphism (SNPs) located within constitutive pigmentation candidate genes SNPs could affect the genes involved in UV response, vitamin D status, and skin tanning response. There is also crosstalk between melanogenic and oxidative stress response signaling pathways. Genetic polymorphism of variation pigmentation requires further understanding of the effects on target proteins and correlation within the cellular functions.
Next, we move to the structural differences and aging properties of ethnic skin type. So, the structural differences and aging properties of ethnic skin types are significant and can be attributed to various genetic, environmental, and physiological factors.
Next, I'll be sharing insight into how skin texture varies across ethnic groups. Difference in skin texture can be divided into two factors. The first one, thickness and compactness, and the second one, melanosome size and distribution. Let's start with thickness and compactness. African and Asian skin types generally have a thicker and more compact dermis compared to Caucasian skin. This is largely due to larger, more active fibroblasts, the cells responsible for producing collagen. As a result, these skin types maintain elasticity better and show resilience against aging and photoaging. Next, melanosome size and distribution. Melanosomes are the organelles that contain melanin, the pigment that gives skin its color. In darker skin, melanosomes are larger and more evenly distributed. This provides greater protection against UV radiation. On the other hand, fair skin has smaller melanosome and less melanin, which makes it more prone to UV damage and photo damage.
So next, we will move on to the second part with its aging properties. First and foremost, we have wrinkle formation. So in African and Asian skin types tend to show a delayed appearance of wrinkles due to their thicker dermis and better preservation of elasticity. In contrast, Caucasian skin often exhibits more pronounced signs of intrinsic aging, such as wrinkles and loss of elasticity, due to a thinner dermis and less melanin. Next, we have pigmentation changes. While darker skin types are generally more resistant to wrinkles, they are more prone to age-related changes in pigmentation, such as hyperpigmentation and dyspigmentation. This is particularly evident in Oriental and Asian skin, where uneven pigment distribution can occur with age. Last, we have photo damage. Caucasian skin is more susceptible to photo damage, leading to conditions like solar elastosis, abnormal elastin accumulation, and telangiectasia, dilated blood vessels. In contrast, African skin shows more resilience to photo damage but may develop hypertrophic scarring and colorates more frequently.
The third one is hydration and barrier function. The first one is transcutaneous penetration. African skin is noted for its resistance to transcutaneous penetration, while Caucasian skin shows stronger resistance to water barrier damage. This difference can affect how various skincare products are absorbed and their overall effectiveness. The second one is skin hydration. Ethnic differences also manifest in skin hydration levels, with African skin often experiencing more pronounced dryness and xerosis, especially in low humidity conditions and during aging.
Alright, we settled with all of that. In summary, the structural differences in ethnic skin types significantly influence their aging properties with variation in thickness, pigmentation, and hydration levels, leading to distinct responses to environmental stressors and aging processes. Therefore, understanding these differences is crucial for developing personalized skincare solutions that cater to the unique needs of each skin type.
Now I'm going to move on to personalized skincare application. Analyzing an individual's genetic makeup, gene expressions, proteins, and metabolites allows for a better knowledge of their skin distinct demands and how it responds to external variables such as aging, UV exposure, and environment. This is why the use of Omics data in skincare provides a game-changing approach to personalized dermatology. Skin phenotypes are also evident within the major ethnic groups. For example, degree of pigmentation and dermal elasticity are the individual characteristics determined by both genetics and environmental vectors. Different reactivity of the tissue to chemical vectors may be caused by individual and ethnic differences in skin physiology and structure. We take sunscreen as an example. For the purpose of personalized skincare, both the skin type and environment should be taken into account as the skin is exposed to varied levels of air pollutant on a daily basis. Sunscreen with a well-balanced sun protection factor were demonstrated to prevent UVA-induced expression of the gene linked to the oxidative stress response, which are prone to wrinkles, while sunscreen with shorter wavelength UV that damage the epidermis would be more beneficial for darkly pigmented skin.
There are multiple benefits of personalized skincare, such as first is targeted solutions. Personalized skincare products are specifically designed to address unique skin concerns, and this leads to more effective results for individuals. By understanding the specific needs of each patient, dermatologists can select the most effective methods and ingredients depends on the skin condition like acne, dryness, or pigmentation issues. And patient experience improved results and satisfaction when their skincare regimens are customized to their needs, reducing trial and error with generic products. Second is ingredient optimization. Personalized skincare allows for the inclusion of active ingredients that best suit the individual's skin type and concern. By optimizing the ingredient selection, dermatologists can ensure that the formulation are effective in delivering the desired results. Tailored products also can help reduce the likelihood of adverse reactions by avoiding ingredients that may be irritating or unsuitable for certain skin types. And third is skin type consideration. By skin types vary widely, and an individualized classification of skin types enable clinicians to develop personalized treatment plans. And analyzing an individual's skin physiology and characteristics is crucial, and this includes factors like oiliness, sensitivity, and age-related change. Clinicians must consider the patient's skin type when selecting cosmetics products and procedures, and this ensures that the treatment enhances skin health, leading to better outcomes. Fourth, holistic approach. Personalized skincare goes beyond just topical treatments. It integrates lifestyle, dietary, and environmental factors that affect skin health. Educating patients on how their lifestyle choices impact their skin can empower them to make informed decisions about their skincare routines. A holistic approach can lead to sustained improvements as patients adopt habits that promote overall skin health. And number five, enhance patient satisfaction. When patients feel that their specific needs are being met, their satisfaction with the treatment process increases significantly. Personalized skincare encourages open communication between patients and dermatologists, allowing for adjustment based on feedback and evolving skin needs. As patients see tangible results from customized treatments, their trust in dermatological expertise strengthens, leading to long-term patient-dermatologist relationship.
Next, we go to the future directions in personalized skincare. First, personalized treatment. Genetic research helps create skincare products that work best for each person's unique needs. Second, using health data. Electronic health records can show a complete picture of someone's skin health. And the last one is better research databases. Studies are needed to understand how people use skincare products and how these interact with different environments.
To conclude this presentation, Omics data in skincare studies genes, proteins, and molecules to create treatments tailored to individual needs, like aging or sensitivity. This advanced approach is more effective than generic products, offering better targeted solutions for all skin types. This is the reference, and thank you for watching.